Hello, my name is Christina Nguyen, and I'm intending to major in chemical engineering.
My name is Justin Schedivy, and I am intending to major in biomedical engineering.
My name is Peterson, and I'm undecided.
My name is McNeill, and I'm planning to major in computer science.
And we are the Assistive Device Team, or the A-Team. If you haven't already guessed by our team name, our project was the Assistive Device Project. For FEDD, we had to create a product that would help a person or animal with a disability and improve their quality of life. Following the engineering design cycle, our group created an adaptable utensil aid for those living with arthritis.
The guidelines for the assistive device project were fairly broad, so we spent our first 2 meetings defining our problem. First, we did research on different physical disabilities that we may have been able to create an assistive device for. After narrowing down our options and choosing to create a device that addresses the arthritis, we brainstormed everyday activities that require the use of hands. We were considering creating devices that would help someone with arthritis type, fold clothes, cook, write, or play sports. We eventually decided settling on addressing the obstacles that someone with arthritis might face when writing.
We began imagining different assistive writing devices by researching existing designs. We found that there were already many assistive writing devices with slightly different designs on the market. When researching these products, we concluded that each design was always specific to one utensil, whether that be a pencil, paintbrush, or even eating utensils like forks and spoons. Additionally, we realized that a lot of these devices were extremely expensive. It would be unrealistic for an individual living with arthritis to buy multiple devices without having to break the bank. Realizing that there were already assistive writing products on the market, we decided that we would create a device that accommodates a variety of utensils that would be affordable. This would require an adjustable component to our design.
Collectively and individually, in our own design notebooks, we drew sketches of different ideas for adaptable assistive writing devices. Nearly all of the designs consisted of some clamp component in order for the device to be adaptable. We also recognized that inside of the clamp, there needed to be some kind of grippy material to prevent the utensil from sliding out of the clamp. With these factors in mind, we decided to begin prototyping with a pinch-activated clamp with a silicone cornstarch material inside the clamp.
When it came time to creating our adaptable utensil aid, Austin already had 3D printing plastic available, so we just used his materials to print out the device in the makerspace at DH Hill. Our first prototype took about an hour to print, and all the subsequent prototypes took more or less the same amount of time. In addition to using the makerspace at DH Hill, Justin also utilized his RI's 3D printer to save time and money. Ultimately, we created 3 different types of prototypes for our adaptable device. For the silicone mold to fit our device, Justin obtained silicone and cornstarch from Amazon and the grocery store and mixed the two together.
We initially planned to test our device with relatives who have arthritis. Unfortunately, due to distance or living arrangements, we were unable to test the device in this way. This was a major problem we encountered during the design process, and our testing was likely not as effective as it could have been. We instead settled for testing the device ourselves and evaluating how effective we thought it would be. Since our device is supposed to be adaptable to many kinds of utensils, we tested our product with multiple items. We were able to test our device with pencils, pens, expo markers, spoons, forks, and toothbrushes. Based on our own testing, we were able to identify and improve on certain problems in the design.
The initial clamp design was found to be too difficult to clamp or release, and did not offer a great amount of variation in the size of utensil and intensity of the clamp. To rectify this, our next prototype instead utilized a new clamp design that was larger and could be easily tightened by steps. This design was then modified to allow the clamp to be easily undone by pulling the adjustable arm up along the bar connecting it to the other arm. Our silicone mold also needed to be altered into 2 separate edges on each arm of the clamp to accommodate the new design and larger utensils.
During this process, we had challenges regarding testing our prototype. Because all of us live on a college campus and our assistive device addresses arthritis, it was kind of hard to find someone to test our device on. We eventually settled on testing our device on Austin's great aunt. However, because of time constraints and obstacles involving where Austin's great aunt lives, we were not able to accurately test our device. As an alternative, though, we tested our device on ourselves by simulating physical symptoms of arthritis, and the device worked well. At FEDD, we did not place, and we were unable to view our ranking on the FEDD mobile app. However, multiple people did come up to us and tell us that we should put a patent on our product and put it on the market. Additionally, we also had a lot of elderly come up to us and express great interest in our device. If we had the opportunity to do things differently, we would have developed a better plan for testing our device. I think that when we first began our design process, we were so concerned with defining our problem and developing a working prototype that we didn't accurately evaluate how important testing was. However, after going through this whole process and realizing how important testing the device is, we would have more accurately organized the necessary materials or people needed to test the device. Something we would tell future students while working on their FEDD projects is to communicate effectively to your other team members. This means listening to their input and ideas, and if there is an issue, don't be afraid to raise your voice to your team members or your professor. With any team, there's bound to be different ideas and misinterpretation. It is your job as team members to work together and complete the project. Another piece of advice we would give is to plan a schedule and stick to it. It is very easy to get off track or push behind a deadline. But since FEDD is really important, it is pertinent that you and your group stays on track.